Sixth grade lesson 8.5 is modeling and solving multiplication equations. So we're going to go back to looking at those algebra tiles again. So quick reminder, the long bar of the algebra tiles represents that x, that variable. And it represents one variable. And the squares, the little tile, represents 1. So they start off by asking us to model the equation 3x equals 15. So we'll get our mat, and on one side of the equation we'll put 3 x bars, 1, 2, 3, and on the other side of the equation we'll put 15 ones across here. And there we go. I have 3 x's equal 15 ones. Okay. So if I want to find out the value of 1x, I would need to divide this up into 3 separate pieces. And then, of course, I would divide this up into 3 separate pieces equally. So it would look like this. 1x gives me 5 on all of these. So I'm dividing them up equally, both sides of the equation. And what I find out is that 1x equals 5. And if you think about in the previous lesson where they talked about inverse operations and isolating the variable, and we had our scale looking like that on both sides of the equation. Inverse operation, well, here's my variable and I want him isolated. He's being multiplied by 3. Inverse operation, opposite of multiplication by 3 is division by 3, which is what we did. We divided those into 3 pieces. So if I divide by 3 on this side of the equation, divide by 3, and same applies as long as I do the same on the other side of the scale, divide by 3. 3 divided by 3 is 1. That leaves me with just 1x. 15 divided by 3 is 5. So that was kind of a preview into the next lesson. This lesson is all about seeing it modeled, but this is where it's going with it. It's the same idea as those previous lessons. You use the inverse operation to isolate the variable. As long as you do the same to both sides of the equation, then it stays equal. Let's look at another one to model. We have 2x's equals 6. So I'm going to go ahead and put my 2x's here, 1x and 2x, and then I have 6 on this side, and I know I'm going to be splitting these into 2 equal pieces, so I'm going to just kind of hand them out to each until I have a total of 6. 1, 2, 3, 4, 5, 6, and so then when we divide them up, 1x has a value of 3. That's how we do that. Again, as a preview for the next lesson, this is my scale, equal. We keep them balanced. Isolate the variable. Here's my variable. He's being multiplied by 2. The inverse of multiply by 2 is to divide by 2. Divide by 2 to both sides of the equation. 2 divided by 2 is 1, so there's just 1x there. And 6 divided by 2 is 3. So that's the way you will be solving them, but this lesson does a nice job of helping you see why that works every time. We'll look at one more. Okay, we're going to model 4 equals 4x, and your brain might be going, wait, this variable's on the other side. And when you first see that happen the first few times, your brain kind of tries to put the brakes on. That's not right. It's okay. It doesn't matter which side of the equation the variable's on, as long as you know your goal is to isolate it. So we'll model that. We have 4 x's on this side. And then over here, just 4 ones, and I'm going to pass them out evenly amongst my x's here because they're sharing fairly. 1, 2, 3, 4. Then I will divide by 4, which puts each x at having 1. And so to see the preview for the next lesson, that's my scale. I need to isolate my variable. My variable is x. He's being multiplied by 4. The inverse of multiplied by 4 is to divide by 4. So divide by 4, as long as I do that to the both sides of the equation. 4 divided by 4 is 1, so that leaves me with 1x sitting there. And 4 divided by 4 on this side is 1, x equals 1. So here's the visual to that, and here's the calculation to that. Give you a head start again into the next one. That's all this lesson is doing, is model it. But if you find yourself, after modeling a few of them and drawing the models of them, and you feel comfortable enough just solving it with this sort of thing going on, feel free to go into that. As far as I'm concerned, I'm good with that. It's the next step. So if you get that extra practice, that's good.